Today, we'll see how functions combine added, subtracted, multiplied, divided, and composed to describe real situations. We'll use simple example, producing and selling mugs. Let's begin with adding functions. The sum is given by the following equation. To apply this, consider two processes, molding and painting mugs. Suppose you are producing X number of mugs, and let the cost of molding be m of x and painting be p of x. Then the total cost for producing X mugs is m of x plus p of x. Then we proceed by computing the sum. Substitution of the functions and simplification of the expression gives us the expression of the sum. So, how much does it cost to produce 10 mugs? If you use the expression of the sum by substituting x equals 10, then sum computation gives us 1000. We can check this by computing the cost of molding and painting separately. By adding these results, we get the answer 1000, which is the same value when we use the sum expression we obtained earlier. Subtraction. The difference in the function is computed according to this.
Consider the computation of profits. Let C of X be the cost for molding and painting X mugs. R of X be the revenue for selling the same number of mugs. Then the profit is given by the difference. Substituting and simplifying gives us this expression. So the profit, being a difference of the revenue and the cost, can be computed and analyzed using this equation. For instance, how much is the profit for selling 10 mugs? This turns out to be negative 100. How about 15 mugs? The profit is 0. And lastly, when x is at least 15, say x equals 20, we are gaining. Now let's talk about multiplying functions. In this example, we'll be dealing with commission. Say the commission rate is given by the function s of x. For example, the commission rate for selling 10 mugs, according to this function, is 2%. That is, selling 10 mugs will give you 2% sales commission. Now, the commission is based on the revenue. So let's use our revenue earlier. Hence, the amount of commission on selling X mugs is given by the product S of X times R of X. By substitution, we obtain an expression for the amount of commission in terms of the number of mugs sold. Now, how much is the commission on selling 50 mugs? A direct substitution gives us 450. To check, the rate of commission on selling 50 mugs, according to the function, is 0.1. Since the revenue for selling 50 mugs is 4,500, then 0.1 of 4,500 is exactly 450. Moving on to the quotient of functions or dividing functions, This is how we define the division. Suppose we sell boxes of mugs. Then the number of boxes, n of x, is the number of mugs produced divided by 10. Using the profit function we obtained earlier, the quotient, p of x over n of x, is the profit per box as a function of the number of mugs sold. We substitute and simplify to obtain the expression of the profit per box. A question one may ask: suppose 1,000 mugs were sold in boxes of 10. How much is the profit per box? Letting x equals 1,000 the expression of the quotient gives us 199.7 per box. And finally, for composition of functions, let's consider the notion of taxation. Suppose that the tax for the profit of x is given by this function. Using our profit function, we are interested with the tax on profit for selling x mugs. The composition is precisely the amount of tax. To compute this expression, we substitute the expression of p of x to every occurrence of x in I of x, and then we simplify. A natural question to ask is, what is the tax on the profit for selling 50 mugs? A simple substitution gives 35, and this corresponds to the profit of 700. Algebra functions connects processes. Each operation add, subtract, multiply, divide, and compose shows a way quantities interact. That's how we turn everyday problems into mathematical form.